Now, a huge welcome to Cultivate Africa, your virtual talk series designed to create a vibrant Pan-African community for everyone passionate about agriculture. Our mission is very simple. We want to bring together farmers, agronomists, researchers, and students to share their knowledge, discuss pressing challenges, and explore the innovative opportunities that is shaping our continent's soil. Now, to officially begin, we are truly privileged to have with us Dr. Richard Ferguson. Dr. Richard Ferguson is a professor of soil science in the Department of Agronomy and Horticulture at the University of Nebraska-Lincoln, and the former Vice Chancellor of the Rwanda Institute for Conservation Agriculture, RICA. He will be unpacking different climate-smart practices that boost yields. Dr. Ferguson, the screen is all yours.
Thank you very much, Robert. And it is my privilege to join you virtually today. I miss being in Rwanda, especially today. It's very just introduced, focused on climate smart practices that can impact. As Robert shared, I have been a professor of soil scientist at the University of Nebraska up until 2 weeks ago when I retired from the university. So I'm officially an emeritus professor now. Still very much engaged in activities in the department, and I appreciate the opportunity to share in endeavors like this that engage beyond this university and this state. So I was a professor of soil science at the University of Nebraska for over 40 years. And my focus in that time was soil fertility management practices that increase profitability and production for Nebraska farmers, at least initially, but also that minimize the impact of fertilizer use on the environment. Then for a significant part of my career, that focus expanded to include what became precision agriculture. So the science of understanding soil spatial variability and temporal variability and managing crop inputs accordingly based on that variation. And then as Robert shared, I had the unique opportunity for about 5 years to serve as the inaugural Vice Chancellor of the Rwanda Institute for Conservation Agriculture. And so in that role, which ran from 2019 through early 2024, my focus was primarily in academic administration, not so much the science and education of conservation agriculture. So unfortunately, my hands-on experience with cropping systems and conservation practices in Africa is not extensive, but I've worked for a while with a lot of people who have that experience, and then have benefited very much from engagement with them. So to introduce a bit of the perspective, cropping systems in Nebraska are quite different from what you would find in Eastern Africa, but maybe not dissimilar to what you might find in some situations in South Africa. So Nebraska is characterized by soils that originated as grasslands. The landscape is typically very flat. The rainfall patterns vary significantly across the state, from around 300 millimeters to over 800 millimeters annual rainfall. Consequently, much of the state to raise high yields of crops requires irrigation. So this photograph shows a fairly typical field being planted to maize in central Nebraska about this time of the year, probably a little bit later, late March or early April, with a center pivot irrigation system in the background. In contrast, the landscapes and soils of Rwanda and East Africa are much different. This image is from the Gakenke district in north central Rwanda. Soils here are volcanic in origin. The landscape is very steep, mountainous, and rolling, and farmers farm on a much smaller scale with very little mechanization. But at its core, the issues that farmers in Rwanda and farmers in Nebraska face are very similar. They would like to make the most money they can, ensure that they have things to eat on a daily basis, while at the same time understanding the landscape and how to protect and maintain that in a way that it is productive into the future for themselves and for those who follow and as stewards of the landscape. So often it boils down to very similar practices that farmers in Rwanda and farmers in Nebraska would like to use or need to use, although the way that they go about that can vary. So much of what would be done on this landscape in northern Rwanda will be done by hand at a much smaller scale than what will be done mechanically at larger scales in Nebraska. This farmer in the Gashora district, very close to the campus of the Rwanda Institute for Conservation Agriculture, I would say, though I don't know her, I would say that she knows her land. She understands areas of her land that are more and less productive. She and her ancestors have developed practices that, to the best of their knowledge, work well for them. They can use the practices that have been handed down from generation to generation to ensure that they have food to eat and sometimes have food to sell for income. So we should not dismiss the inherent knowledge that farmers have of their landscape and how to grow food, either in Rwanda or Nebraska. And yet, through science primarily and experience, we've learned that there are practices that have come along that help us do a better job of producing crops and protecting the landscape than maybe what we've used in the past. So you may be able to see that she's doing primary tillage ahead of planting. The soil is probably fairly wet. So this is in a river basin area along the Nyabarongo River in Gashora. Likely it's poorly drained soil. Could be fairly productive with the right weather conditions. And yet she's doing tillage that may not really be necessary. As we've learned through experience and research, it's okay and it's quite feasible to grow crops without significant primary tillage. And in fact, the primary tillage that she's doing may be detrimental to yields some years and to the soil quality in general over time. One thing I would like to clarify from the start is what I may call brands of agriculture. So when I started my experience in Africa, this was in October of 2018, I was attending the second Africa Congress on Conservation Agriculture in South Africa. And I was still learning what conservation agriculture meant in Africa compared to how we understand it in Nebraska. But I was struck by a comment by one of the attendees during a question and answer session during that conference. Again, remember the conference title was the Congress of Conservation Agriculture across Africa. And one of the attendees raised concern about climate smart agriculture, that farmers and those who advise them were switching over to climate smart agriculture instead of conservation agriculture. And she was concerned that conservation agriculture would lose out to this new, at the time, branding of practices called climate smart agriculture. So I'd like to caution you against falling into that trap. To me, and I observed when I was in Africa from time to time, different groups would come along with their own version of what they felt like were the practices that farmers should be using. And there would be different names assigned to those brands of agriculture. So besides conservation agriculture, it was often called regenerative agriculture, climate smart agriculture, sustainable agriculture, smart farming, ecological intensification agriculture. Often those might be packaged into what one group or another says this is what farmers in Africa or anywhere in the world actually should be doing. And that may or may not be the case. Usually those improved brands of agriculture are set against what farmers are doing to be called conventional agriculture. So conventional agriculture is defined as whatever farmers have been doing that they're being encouraged to move away from. And yet farmers have much experience on their landscape, experience and knowledge that's been handed down from their ancestors. So we should not discount that, but we should encourage them to adopt practices that are relevant to their situation and especially to their soils and to their climate. So I would encourage you not to be so concerned about the name, whether it's climate smart or conventional or conservation, and rather focus on the practices that are being used and to think about practices that might be appropriate given the soils and the climate and the experience of a particular farmer in wherever you are in the world. Practices that we might use in Nebraska may or may not be relevant to Rwanda. Certainly, the way we adopt those practices may not be relevant given the scale and economics of farming in Nebraska versus East Africa. So, the practices that I'll be talking about could be called climate smart. They could be called conservation agriculture. They could be called sustainable ag. If I were to go on to differentiate then conservation versus climate smart, I would say climate smart, from my perspective, allows farmers to have more resilience to variation in climate. As the global climate warms and weather events become more extreme, these practices allow you to continue to grow crops with some ability to avoid the stress resulting from those climate variations. Conservation agriculture, at least in my opinion, focuses more on maintaining and building soil quality or soil health, which is very beneficial long term and maybe in the short term in terms of yield and productivity. And yet the practices to build and maintain soil health and to provide resilience against climate variation are often the same thing. They just fall under different names that people have given them. The second concept I'd like to come into and stress here is something that I learned very early on as a student of soil fertility. It is called Liebig's Law of the Minimum. And this concept was popularized by Justus von Liebig, who is a German scientist. He was an academic at the University of Gießen in Germany in the 1800s. And he popularized the concept developed by a contemporary, Carl Sprengel. And the idea is that plant growth is limited by the scarcest resource rather than the total amount of resources available. His focus was on plant nutrients particularly, but the idea applies to anything that influences plant growth. This concept could can be illustrated and this is often done in textbooks by this barrel. And the barrel has staves of uneven length, with the idea that the shortest stave is going to be the highest level of water that can be stored in the barrel. If you have other staves that are higher, you still cannot force any more water to stay in the barrel than what the shortest stave will allow. So it's illustrated in this graphic here by a stave representing phosphorus being the most limiting factor. So you cannot fill this barrel, any more than the stave that's labeled phosphorus would allow. So this is an idea that if phosphorus is limiting in your soil, applying more nitrogen or boron or more water or more sun is not going to allow you to achieve greater yields, because phosphorus is limiting and nothing is going to change the capacity of plant growth until one addresses the limiting factor of phosphorus. So besides plant nutrients, this applies to other resources as well, illustrated by the staves labeled temperature, water, sunlight. Thinking of this concept in terms of conservation agriculture or climate smart agriculture, to me, means that farmers really need to understand the factors that are limiting yield and address those. And addressing other factors is not going to increase their yield capacity or to increase their potential to make money until they address the most limiting factor. To illustrate this, I have a first of several videos that I'd like to share, and hopefully video plays well and you can hear the sound. So let me start it here. This is a video shared with me from faculty at the Rwanda Institute for Conservation Agriculture. This is a field on the campus immediately after a very intense rainstorm. And it was while this field was being developed for production and research and teaching on the campus. And what we're seeing here is a tragedy, I would say. It's something that a farmer never wants to see on their field. If I can go on to a still image of this. You can see in the background, this field is irrigated with a center pivot irrigation system, but obviously no need for that at this point. I believe this occurred during the spring rains, the long growing season, probably in April in a year in the past. And it's an example of what can happen when environmental conditions exceed the capacity of a soil or a landscape to absorb the conditions. So in this case, a very intense rainfall. This occurred while this field was in transition from what had been brush. So it was non-cropped. It had been in trees and wild growth for a number of years, a number of decades, actually. And the landscape was then being cleared with heavy tillage and bulldozers, actually, to allow the field to be turned into a productive field again. And yet the capacity of this field to produce crops in the future is being lowered because of this loss of soil. And this loss of soil is something that cannot be replaced in any short time. Soil erosion like this is losing resources that will take decades to replace on this field. Now, it's possible to change practices, which has occurred on this field, to gradually rebuild soil health and soil quality. But the loss of soil through erosion, primarily water erosion, is a major issue in Rwanda. And the fields that I showed you earlier in Gakenke district with the slopes that they have and bare soil lead to significant erosion every year. That's a major factor in impacting the productivity of soils in Rwanda, and I think probably much of East Africa. I had the opportunity to be in northern Kenya about 2 weeks ago. I returned from there and was sent this video on the left of primary tillage being done in advance of the rainy season. So I'll play this video. Okay, so what you note from that video is that primary tillage is being done in preparation for the growing season, which probably has started by now. I think I saw yesterday there was some significant flooding occurring in Nairobi and parts of Kenya, actually. But at the time this tillage is occurring, we see dust. So probably this soil is dry enough that it's acceptable to do primary tillage, but is it necessary? So primary tillage reduces organic matter over time. It leaves the soil vulnerable to erosion. So this video was taken in eastern Kenya. If significant heavy rains are occurring on this field before the crop is starting to grow, this site is going to be subject to significant erosion, I would guess. This field in general looks fairly flat, and it's a little bit larger scale agriculture than some other parts of Kenya and Rwanda. And yet, the likelihood is that this tillage is doing more harm than good. It may provide the good seed bed that the farmers would like, but over time, they're going to be gradually losing organic matter and productivity due to this tillage. This next image is one that I took when we were in the Rift Valley to the west of Nairobi last month. And it's an image of a plow, a disc plow that's come from the field. It's here fueling actually at a service station. But if you look at the soil on the plow, it's evident that this plow has been operated under very wet soil conditions. Probably it was dry enough for the tractor to get into the field, but it was way too wet to be doing any tillage, if tillage is done at all. So tillage under these conditions has the significant potential to produce a compaction layer, which then can permanently, more or less, restrict capacity to grow crops in the future. So this next video on the left is some of the group that I was with in the Rift Valley. We're using a hoe to excavate soil down to a depth at which we then found a compaction layer. And I would say these soils, from my observation, without any analysis, seem to be highly productive. They seem to be high in organic matter content, soils that would be highly productive given the right conditions and climate. So let me show the video here. So we're excavating the soil and eventually down to a depth of about 20 centimeters, I believe. And these, some of these folks are farmers in the Rift Valley, and then some others are advisors who came with me from Nebraska. And what we see at the bottom of this excavation, I'll show you in the still image, at about 20 centimeters is a layer of different soil color and soil density. So what we see, and this was in late February, is that the early spring or rainy season rains have occurred and there's decent soil moisture stored to a depth of about 20 centimeters. But what we hit then at a depth of 20 centimeters is a significant compaction layer caused by primary tillage. And this compaction layer, for one thing, you can see that it's slightly a different color. Some of that's due to soils being lower in organic matter content as we go deeper in the profile. But the different color is primarily due to no water entering this compaction layer. So the compaction is so deep, dense that water will not infiltrate and plant roots do not penetrate. So you can see a little bit in terms of plant root development from the prior crop of lateral growth. Roots are reaching that compaction layer and growing horizontally instead of vertically because they cannot penetrate that compaction layer. And then this last video on the right is Eastern Kenya. One of my colleagues from Kenya sent me this video of a field where they had removed the topsoil, again, 15 to 20 centimeters deep. I found a compaction layer then, and then are trying to use a pickaxe to break up the compaction layer. Now, obviously, to do this on any scale at all is going to be tedious, laborious, very expensive, and not really practical. Now, the answer to that, at least in a mechanized sense, is to break through that compaction layer. So this is a ripper, a 3-tine deep ripper that we used on the campus of the Rwanda Institute for Conservation Agriculture. This image was taken, I believe, in 2021 as we were preparing fields which had been a construction zone. So as campus construction occurred, there'd been a lot of heavy equipment trafficking what would become agricultural fields. You can see the excavation showing in the background. That heavy equipment and compaction has resulted in significant compaction layers then that we use this ripper to be able to break up. So once those compaction layers are broken up, and this needs to occur when the soils are relatively dry, so that the compaction layer shatters rather than just a slice created. If the soils are too wet, when you do deep ripping, it's not going to really help. You need to shatter the compaction layer and then not create it again. So the best way to avoid creating a compaction layer is to avoid primary tillage, to avoid, even with a hoe, significant deep primary tillage. If you do have it, deep ripping is about the only way to get rid of it. So if primary tillage compaction has occurred through hand tools, it's a challenge. There are not good ways to break up that compaction layer by hand. So a good lesson is to not create it in the first place. If it is created, then find ways to break that compaction layer up, and then in the future not recreate it by avoiding primary tillage, especially primary tillage when the soil is too wet, as illustrated by that plow that I showed you earlier. Okay, earlier I encouraged you to not be overly concerned about the name or brand of agriculture and instead think about the practices that are being used in ways to increase productivity and optimize yield. When I was at the Rwanda Institute for Conservation Agriculture, the faculty there developed these set of practices, which to them and still to me today represents what we think should be taught and then practiced relative to conservation. So the first group of practices encompass what the United Nations FAO defines as conservation agriculture. So that definition has three components. The first, to minimize tillage. The second, to maintain soil cover, either through residues or cover crops. And the third, to diversify crops through rotation or intercropping. Now, those are all excellent practices, whether you're in Nebraska or East Africa. Things that I have been suggesting need to be done through the illustrations already, but to me, do not totally define what should be conservation agriculture. This definition, for example, does not address livestock or ecological impacts of agriculture. So the faculty at RICA, the Rwanda Institute for Conservation Agriculture, expanded this definition to include other factors they felt were important to consider. One was to implement spatially appropriate cropping and livestock systems, and I'll come back and address this in more detail with another slide. The next three were to apply inputs based on potential for economic response, not necessarily maximizing yield. So nutrient inputs like fertilizer in this case, or pesticides, or irrigation water should depend on the combination of the added value that you gain by increasing yield with the cost for implementing those practices. So chasing the highest yield is not always the most profitable. Farmers should be encouraged to adopt and use inputs in ways that maximize their profit, not necessarily yield. And we find from research in the US that often when we're maximizing profit, that tends to minimize environmental impacts as well. But we explicitly list that as a practice that farmers should be aware of, to manage crop and livestock systems to minimize environmental impacts, both for short-term benefit and then long-term sustainability. We feel it's important to integrate livestock and crop production systems and use manure in such a way that recognizes its value and not just to dispose of it. That's a practice that's commonly widely been used in Nebraska in the past to get rid of manure instead of effectively utilize it. Today, that's recognized that that's wasteful, but in the past, that was not always the case. We should be aware that we produce byproducts from food processing and other processes that are beneficial to the land. So we should use those whenever possible and not put them in landfills or dispose of them in ways that have negative environmental impacts. And then finally, we should explore ways to promote diversity, biological diversity on the landscape through crop rotations and livestock systems. This aerial image is one that illustrates the concept of landscape variation. It was collected with a drone or a UAV on the RICA campus in late December of 2023. It's a multispectral image, so it's using a sensor on a drone that looks at crop reflectance both in visible wavelengths that our eyes can see, and then a near infrared wavelength that our eyes cannot see, but the sensor can. So when we combine these reflectances in different wavelengths into a vegetation index, it allows us to see variation in the landscape that we can't see with our eyes. This is a 70-hectare pasture, so it's in grass. This image was taken in December, so it's during the dry season, towards the end of the short dry season in Rwanda. Parts of the image that you see that are in orange or yellow are lower in vegetation. The image that's darker green is higher vegetation. So this pasture is being harvested through grazing. There's no manual or mechanized harvesting. It's just by dairy cows grazing this field. Areas that are green have more growth and are more beneficial to the livestock that are grazing. Those areas that are in green result from both natural variation and man-made variation. So we see some very linear patterns. Those are likely due to either land modification or fencing. There are fences that cross this pasture to manage the grazing habits of the cattle. But then we see patterns that are nonlinear, more random, and those are natural variations. In this case, lower landscape areas, at least within the pasture field, lower landscape areas that tend to accumulate water more. And so that here in December still have more vegetative growth than areas that are more, that don't have as much water available. This is an illustration that soils vary, and they vary because of natural factors or also man-made factors. And farmers should understand variation in their fields, regardless of the size of their field, and manage according to that variation. Understanding why the variation occurs may be challenging in some cases, but they can note through observations of the crop that areas of the field do better, some areas of the field do not do as well over different growing seasons. Okay, the field that I showed you earlier that was experiencing major erosion due to water running off the field, this is the same field years later. I'm not sure, 2 or 3 years later. So a no-till planter, in this case, a no-till drill, is being used, in this case, to seed soybean onto this field, which had been in maize the prior growing season. And this drill is capable of planting through this heavy layer of crop residue, placing the seed into the soil, into moist soil in a way that the crop can come up through this residue. This is an example on a different field of a maize crop emerging through crop residue. So in this case, this has been planted with a planter, which singulates seed rather than a drill, which is used for smaller seeded crops. But the planter is capable of placing seed in the furrow in a way that allows it to emerge through the crop residue. This field is not irrigated. This is a rain-fed field on the RICA campus, adjacent to one of the lakes that borders the campus. This is what the field looks like then a few weeks later in the growing season. This residue has allowed this rain-fed or non-irrigated field to store water instead of have water run off into the lake. So water is being stored and protected from evaporation loss by the heavy residue layer, allowing it to be resilient to periods of dry weather that occur from time to time. This is a demonstration of this practice. This is on at the National Irrigation Project, which is affiliated with RICA. It's in the southeast part of Rwanda in Kirehe district. This demonstration has been created to illustrate the value of conservation practices. So the plot on the left is using conservation practices, no-till, residue left on the soil surface. The plot on the right is conventionally tilled with minimal residue cover. And then these blocks are separated by concrete barriers to prevent water from moving from one treatment or one plot to another. So evidently this image was taken during a very dry period of the growing season. So the conventionally tilled plot on the right has lost moisture due to tillage. It's also lost moisture from evaporation because of the lack of crop residues. The plot on the left is the ability to retain and store soil water, and the crop is healthy, at least to this point. This is another example from Nebraska from last year's growing season. So one disadvantage, I guess, we have in Nebraska is one growing season a year. East Africa has the advantage of usually 2 growing seasons, sometimes 3 if you have short season crops and irrigation. But this occurred, this is actually a video recorded in June last year. So at this point, the maize crop is at about the 6-leaf stage, I would say. So let me play the video and then we'll discuss it.
This morning I'm out taking sap samples. These will get sent off to a lab here shortly. It's 9 a.m., about 6 hours after a 7-inch rain, and the ground is very, very firm. I'm not even making foot tracks anywhere where I'm stepping. I believe this is a prime example of how soil health pays.
Okay. So some issues that this farmer is raising. One is the collection of leaf samples to send to a laboratory to analyze for nutrient content. He calls them sap samples, but the leaves that he's collecting will be sent to a commercial lab and analyzed to see if, at this growth stage, there are adequate supplies of all nutrients to this crop. You can see that the soil is covered by residue from the prior growing season. And the farmer is out in the field just a short time after a very intense rain. So he said 7 inches. 7 inches of rain is 178 millimeters. That's an extreme rainfall event for Nebraska. It certainly would be extreme for Rwanda or East Africa. It's unusual to see a rainfall that heavy. And yet he's able to walk in the field without any mud on his boots, without his feet sinking into the soil. And he attributes that to what he calls soil health. We would say conservation agriculture or climate smart. He's no-tilling. He's using a cover crop. So the residue that you see is partly from a cover crop, which he destroyed prior to planting, and also from the previous crop growing season. It's an illustration of the climate resilience that can occur with the use of conservation agriculture practices. And then the last video here, before we jump into a summary, this is from Ghana. So it's a short video taken by Dr. Kofi Boa, who's the director of the Center for No-Till Agriculture in Ghana. He's also an adjunct faculty member at the Rwanda Institute for Conservation Agriculture. And this is a cover crop that's being destroyed by a device called a roller crimper.
This is the way we prepare the crops in no-tillage farming. Take vegetation like this is crimped using the roller crimper. And it gives you a very good cover of mulch, completely covering the ground. And this protects the soil surface. So, when we have done this, we follow it up with the roller crimp with the planter, the no-till planter, to do the planting. This is so nice.
Okay, so this is a large biomass cover crop. I would say it's not a cover crop that would be commonly seen in Nebraska. But there are farmers who use cover crops and then a roller crimper to destroy or knock down the cover crop. And then sometime later, usually 2 to 3 weeks later, come in with a no-till planter, which is able to go through a residue layer like this. One caution, I'm not sure where this video was taken. Dr. Boa's site is located near Kumasi, Ghana, in central Ghana. I don't know what the rainfall is there, but it's obviously enough to produce a very robust, healthy cover crop. So the use and growth of a cover crop like this would not be something we would recommend in western Nebraska or maybe northern Kenya, just because the rainfall available would not be enough to support this cover crop, or the cover crop would use too much of the soil moisture to allow the successive cash crop to be successful. So one thing to be aware of is that these practices need to be implemented site specifically according to the soils and the climate and the crops grown in a given area. Just uniform taking one practice from one area and implementing that in another location is not necessarily going to be successful. And then one challenge that we find in Africa is the lack of availability for soil analysis. So I mentioned earlier that we need to address the most limiting soil factors first, most limiting properties first. And yet, without capacity to analyze soil in a lab, it may be hard to know really what is most limiting. This table is a collection of some soil samples taken early on from a field, actually from the field that was being eroded in that early video at RICA. And in this case, so it's samples that are listed on the left with different IDs at two different depths, 10 centimeters or 10 to 30 centimeters. And in general, the soil properties for this field at the time these samples were collected was not too bad. Phosphorus was moderate, organic carbon, other nutrients, cation exchange capacity are all reasonable levels. I would say the most limiting factor for this field is pH. It's in the mid fives. And so based on this information, we did apply lime. Actually, this field has had lime applied to it at least twice in my tenure at RICA. So this is a challenge. It's possible to infer the deficiencies of certain nutrients by plant symptoms. And so I encourage you to become aware with what some of those plant deficiency symptoms might look like. But hopefully the availability of soil analysis in Africa will increase over time, both the availability and the affordability of this type of analysis. So in summary, I'll make an attempt to rank what I would consider to be practices that should be explored. But again, these practices, in terms of their relative importance, will vary from site to site. And so farmers and those who advise them need to discern what really is most important. In Rwanda, and I would say a lot of East Africa, soil erosion is the major factor. Steps need to be taken to limit tillage, retain crop residues, use cover crops to protect against soil erosion. Second, to rotate crops, so don't grow the same crop every year, every season. Particularly by doing so, one can reduce the pressure of pests, weeds, and insects and disease. If you include legumes in crop rotations over time, you'll gradually increase fertility. If you have soil fertility issues like pH or low nutrient levels, apply manure or composted manure first if that's available, and then use commercial fertilizer. When I was in Kenya a couple of weeks ago, I heard from farmers who still were just throwing manure away. They did not recognize the value that it had in terms of maintaining soil health. Of course, use improved seed varieties instead of just replanting the same seed from the same crop year after year. Critically, at least what I've seen across Rwanda and Kenya, is that soil compaction is a big issue. So explore if that's a concern on your fields. If it is, figure out ways to address that through deep ripping. Use pest controls appropriately, so don't overuse pesticides if you have those available. Consider cover crops, but carefully, because they do use moisture, especially. Cover crops that you destroy and return back to the soil do not remove nutrients, but they do remove water. So cover crop is a good thing if you have the capacity to use it. And then if you have the capacity for irrigation, irrigate according to crop water use, not excessively, because excessive irrigation is not going to help. It will tend to leach nutrients out of the soil. So again, and all of these factors address the most limiting one first. Do that in successive order. So with that, I will stop, and hopefully we've left a little time for any questions that you might have. I'll turn it back over to you, Robert.
Thank you very much, Dr. Ferguson. I think this was an insightful presentation. Lots of things I learned, lots of new knowledge I gained. At ShareScreen Africa, we termed conservation agriculture or regenerative agriculture or sustainable farming as soil-friendly farming. We don't want to be stuck in the mix of all those names. We just named it soil-friendly farming. But yeah, we appreciate the principles, and we consider them as the foundations of every system that you want to use, be it conservation agriculture or regenerative agriculture. Now we
Thanks, Robert.
are
I will add soil-friendly farming to my list.
exactly. But we can start with Samuel. I saw his hand earlier. Samuel, if you can unmute and ask your question.
Okay, so Prof, thank you very much for this evening. I was very glad hearing from you because I am an agric student at the University of Cape Coast. So most of the things that you were saying, I did a course related to soil conservation and management. So all these things that we were talking about, I was very glad. I was much appreciative. And my question was on the field that they were taking some samples that you could see that as they were taking, as they were going deep down the soil, you could see that the soil inside is compacted, but on the soil surface, you won't see any compaction. Yes, so that's when I saw the video, it came into my mind. That's why we were taught with the rotation, with the crop rotation, deep root crop should alternate with shallow, whereby you are going to make good use of the nutrients available in the soil, because when you have the deep root crop, that's where these crops are going to grow down within the soil to take up the nutrients. But here is the case: when you are having a land that have deep inside the soil, the soil is being compacted, they're not going to get the maximum yield you expect. But as a farmer, if you go into a crop that, assuming you're having such type of land, there is no need for you to cultivate a crop that its roots are deep. So you should be able to have crop which will have a shallow, deep root system where there wouldn't be any need for the crop to go down inside the soil for it to uptake the nutrients that it needs. And I was much grateful because we were taught the tillage. We have the primary and the secondary, whereby the primary deals with what do you call the deep, turning the soil deep so that you have a maximum, like you get the tilt. But for the secondary, that's where I deal with the shallow. So we are just taking the shallow turning of the soil so that at least your crop residue will mix with the soil so that it will decompose, so that in your next cycle, the nutrient that was lost will be regained by the plant. So I was much appreciative when you brought this. Actually, I don't have any question, but just that I was appreciating the things that you were bringing on board, and I could see that at least what I learned, it is
Okay.
universal, not that it is general. Thank you very much.
Very good. Thanks, Samuel. I appreciate your inputs. Deep-rooted crops. The question when I was in Kenya was, what do we do about that compaction layer if we do not have access to a mechanical tool to deep root? And I didn't have good answers. I would say it depends. I guess that's often the situation for me as a scientist. It just depends on the situation. So in Nebraska, we have use sometimes of a cover crop that is deep rooted. It's called a tillage radish that can penetrate compacted soil and over time break up that compaction layer. We also have the advantage of freeze thaw cycles in soils here that can over time break soil compaction up. Whether those, well, obviously frozen soil is not an option in Rwanda or Kenya. Whether there are crops that can penetrate the compaction layer just depends on the crop, whether it's adapted to the climate, but then also to the compaction density. So if soil is compacted enough, there is no crop that's going to have the capacity to penetrate the compaction layer. It just depends how dense that layer is. And that depends on soil properties, whether the tools that have been used to construct the compaction layer. The other point is, I would say, with a compaction layer at 20 centimeters, there is going to be detrimental impacts on most crops. Even if you have a shallow rooted crop, access to nutrients in the soil and access to water will be limited. I think any crop is going to want to have the capacity to be most productive, to have a rooting system that is deeper than 20 centimeters. So I'll stop there and see if
Sensing, like, can remote sensing, like use of UAVs, solve the challenge of data collection? The technology have its limit when it comes to soil status monitoring. Is it something worth exploring? What is usually done is use outcome crop status as proxy for soil health, but it's not ideal in all cases.
for the question. Certainly, drones, UAVs, satellites can be used to gather spatial information. So I've used them in my research for 30 years now. But the downside is, the positive thing is that they allow us to collect spatial and often temporal information that it's very hard to collect any other way. But the downside is that so far with multispectral imagery, we can't say why with great confidence that those patterns are there. We know there are patterns that differ, and there are certain vegetation indices that have been developed that can give us an insight into why the patterns exist. But at least to this point, it's a challenge to say why they're there. For example, I've used, you're aware that multispectral imagery can be used to create vegetation indices that detect the status of nitrogen in the crop. But that's really more using chlorophyll in the plant as a proxy for nitrogen. And there are other deficiencies that can influence chlorophyll levels besides the lack of nitrogen, magnesium, zinc. So at some level, it's hard with a multispectral image to differentiate zinc deficiency from iron deficiency or nitrogen deficiency. So there is great potential, and I think additional research might allow us to better identify the exact cause of patterns that we see. Certainly, imagery from UAVs, drones, and satellites is a tool that we'll use more and more in Africa.
We have a question from Njambu Chiposa.
Good evening once more again.
Good
My
evening.
question says, how smart agriculture act as a solution to climate change?
Okay, your question is, how do I see agriculture being a solution to? That's an area of significant scientific debate. And personally, I do not see agriculture as being a solution to climate change. I see it as being something which contribute to helping protect against climate change. Climate smart agriculture, as I've defined it earlier, can allow us to use agricultural practices that are resilient, that help us buffer against the impacts of climate change on how crops grow. But there's been a lot of research in terms of carbon sequestration in soils. That's a positive thing that can help reduce climate change over time. But I think probably the primary thing that's going to happen to reduce or lessen the impacts of climate change is to decrease the amount of fossil fuel burning, the use of petroleum products as our primary energy source. The addition of carbon into the atmosphere from that is occurring much more rapidly than we can ever reduce it through agricultural impacts in the short term. In the longer term, someday we will start to benefit climate change, but I don't think it's likely in the short term. That should not prevent farmers from doing practices that reduce the impacts. It's because the adoption of those practices will improve their resilience to climate variation and increase their productivity and profitability, both in the short and long term.
So we have a question from Emmanuel.
Thank you very much, Dr. Ferguson, for a wonderful presentation. I would like to ask, how do you envision precision agriculture technologies to be adopted in Africa, and how they will support conservation agricultural practices? Thank you.
Yeah, great to hear from you, Emmanuel, and great question. I am very optimistic that certain precision agricultural practices will be extremely beneficial over time in smallholder production in Africa. But the way it's adopted, at the scale it's adopted, will be different from what we see here in Nebraska. And certain practices will not be useful just because of the size of fields and the economics involved. So yield mapping, for example, machinery is common in Nebraska, combines that measure yield, but those would be of no use on smallholder farms in Rwanda. In my opinion, satellite imagery is a tool that's going to have potential for great impact. Today, we have the capacity in Nebraska for satellites to collect information daily during the growing season. Farmers are now using that to manage their nitrogen fertilizer on a weekly basis based on satellite data. That's because satellite systems have evolved over the last 5 or 6 years that return every day, and they have the spectral imagery that's necessary for detecting crop stress, and their spatial resolution is down to 1 or 2 meters, so we can understand variation at small detail in small fields even. Now, an individual farmer, smallholder farmer in Kenya or Rwanda is not likely to access daily satellite information. But I think in the near future, it would be feasible for advisors to farmers at the district level or the province level to be able to use satellite imagery to understand what's going on in regions or even in fields, and to provide advice on whether there are pest influences or nutrient stresses that should be addressed during the growing season. I think over time, some of those tools might be helpful to understand soil nutrient levels, That's a science that's still emerging, but there are spectral patterns that can relate to soil nutrient levels independent of what the crop would show. And that might be useful in the future to allow farmers to discern if they have low fertility that they need to address through fertilization. Water management is certainly an area that satellite imagery could be useful for. There are probably other precision ag practices that would be useful, but those are some that initially come to mind.
Hello, Dr. Ferguson. Thank you for the very nice presentation and greetings to everyone on this panel. My question is about the trade-off in terms of how conservation agriculture and impact the yield. Sometimes from several researchers and some publication, conservation agriculture doesn't immediately affect the yield, and some farmers might end up losing hopes for the first year. What's your advice for farmers? How should they balance the short-term productivity with long-term health benefit when they adopt conservation agriculture from conventional agriculture? How should they balance that short-term productivity with the hopes for the long-term productivity? Thank you.
Yeah, thank you, Polycarp. Excellent question. I'm not sure I have an equally excellent answer. Because you're right, in some cases, I would say in many cases, we may not see short-term gains through adoption of these practices. Again, it just depends on one site's specific situation. So leaving residues on the soil surface, for example, is going to help retain moisture in soil to the benefit of crop yield. But in some parts of the world, farmers are plagued with too much water. They need to get rid of water instead of retain it. And so mulching or retaining residues could be detrimental in some of those cases. I would say the protection from erosion is pretty universal. So leaving residues in place to protect soil from erosion, either through water or wind, is going to be a good practice. Just when soil leaves the field, one has lost capacity for a long time in the future. So farmers, even in a short term, may not see much protection or benefit from erosion protection, but within a period of 5 years, I would say in that span, generally they could see benefits. As part of one thing that we often do in Nebraska is have collaborative long-term studies and addressing various questions. And so we published a paper I think it was the end of last year or early this year, looking at results from 10 years of implementing no-till cover cropping on fields here in Nebraska. And after 10 years, we could see no change in organic matter content under two different environments. One was rain-fed in eastern Nebraska, and the other was irrigated in central Nebraska. So under slight conditions, yes, there were some advantages in very shallow layers, but generally no major change yet. So farmers looking for short-term changes in the stored soil organic matter, that's going to take longer than just a decade.
A question from Samuel.
So my question is on how we can conserve the land on a hill, like taking into consideration the topography of the hill. Like if you are having a land that's slant, so how do you conserve these soil at this area? Because we mostly, when it rains, we see that the land is susceptible to erosion, considering the soil erodibility factor. It is high at that area. So how do you conserve soil at that area, taking into consideration when you want to use cover cropping? Because when you use cover cropping, eventually when it rains, this water is going to carry this cover crops that are on the surface. So how do we maximize the conservation of the land in order to get the maximum yield that as a farmer you expect, taking into considering the topography of the land? Thank you very much.
Yeah, very good, Samuel. That kind of goes back to my point of farmers knowing their landscape and the spatial variation of the landscape. So at some point when slope is so extreme, the landscape should not be farmed, at least with annual crops. Production of a permanent crop, such as forage or grass for livestock, would be appropriate. On some land, and it's common to see in Rwanda, landscapes have been terraced. So terraces have been put in place, often by the government, which helps establish some protection against erosion. Still, on terraced fields, you can see erosion occurring if a significant tillage occurs on the fields that are on the terraces. So minimizing tillage, leaving crop residues, establishing cover crops are helpful, but at some point, one just has to acknowledge that the best use for land in some cases is not to produce annual crops. It should be used for other purposes.
So, Prof, I was confused with the, what do you call it? Is it Limbeck law of minimum? Yeah, the law that the man proposed, whereby you could see a barrel taking into consideration the minimum factors that affect these things. I didn't understand it much well. I'll be glad if you could explain it much again so that I could know what are the nutrients to consider when going to cultivation, and what are the what do you call the measures to put in place in order to cater for these losses that has already happened. Yes.
Okay. Well, the point is that there may be some factors limiting crop production that have to be addressed before you can increase potential for yield. So, for example, using that example, say you had a phosphorus soil test of only 3 part per million. If you're to no-till that field or apply more nitrogen or to apply more water, your yield capacity is going to be limited because phosphorus is too low. To really increase the production capacity of the field, one needs to apply phosphorus, either through manure or commercial fertilizer. Another common example in Rwanda is pH. If you have a soil pH of 4, using no-till or applying residues or adding more phosphorus is not going to improve yield capacity much, if any, until one raises the soil pH through the application of the lime. So those are illustrations of Liebig's law. One has to address the factor that's most limiting to benefit from other practices.
One last simple question is, you've sat on different panel in the boardrooms with different government institutions, but also you've been into academia. You've also worked with some of the communities, for instance, in Kenya. My question is, for a government to facilitate farmers, agricultural communities, how best should they do it? Should it come straight from these policies, or should the policies start from the farmers understanding what they need first of all?
Yeah. Oh, Robert, I'm not sure I have a good answer there. Certainly good government policy is critical to maintaining and increasing crop production in a country. From my perspective, I would say information and education. might be the thing that I would think is most easily addressed and most limiting often. It certainly can be a challenge with many farmers who may not read or write. So one has to come up with ways, and there are good ways of communicating information and educating farmers who can't read or write. But just sharing with them these kinds of information about practices that would be helpful to them, I think is often the key. There are many things that revolve around policy that are longer term issues, but just getting good information into the hands of farmers and letting them try things out is often a good place to start, I think.
Thank you. Thank you so much, Dr. Ferguson. I think